Another common problem that you might run into is like this, where you're given four graphs, and you're asked to match them to four derivatives and see what they look like. And it's easier than you think. If I take a problem like this, a function like this is maybe a better thing. Let's say we've got a thing like that. Well, what is this? That's a pretty downward direction. So let's say maybe -5 or something like that. And then you just need to step forward and understand like what you're looking at. Maybe this is a -4. And then eventually it's going to come to 0, right? Because flat is always a slope of 0. Then it's going to be pointed up, so maybe that's a +4. I'm using guesstimated numbers, right? Guesstimated numbers. Then it's going to be 0 here, flat. You definitely want to notice where the zeros are. And then it's going to go negative again, so -4. So I'm looking for something that starts negative, goes to 0, becomes positive, goes to 0, becomes negative. So it's going to look like something negative that comes up to 0, goes to positive, goes to 0, and goes to negative. Well, that's this right there. So first one done. That was easy enough. Let's look at part B. Looks like this. Well, this slope is the same the whole way up. And right here, maybe it's something weird, right? Because if I look at it from the left side, it's pointed up, but if I look at it from the right side, it's pointed way down. So there's some kind of a problem there. That's at the exact same point. It's not really continuous in that way. So we have a slope of like, let's say this is 1. Well, that's a slope of 1 and 1. And then this is something weird. And then this is like -1, -1, -1. The slope is all the same because it's a straight line. And same thing here is like something weird. And then +1, +1. So if I'm looking at the graph, it goes 1, 1, 1, something weird, -1, -1, -1, +1, +1. Clearly, we're looking at this here. And now you see why those open holes are there. Because no matter how much I zoom in, let's say you zoom in on that corner there, no matter how close you get, right next to it the slope is 1 and this slope is like -1. So right at this exact point, you can't really make a claim of what it is. That's called discontinuity. It's not fun in calculus to come upon discontinuity. Still, we've got 2 done at this point already. Let's look at C. So the graph looks like this. And it doesn't matter where it is. It doesn't matter if it's on the axis or way high or what, because we're only looking at the slopes. The slope here is basically flat, so we'll say 0. And this kind of tilting down a little, so let's just say -1/4. Down a little more, maybe -1/2. Down a little more, maybe -3/4. Doesn't matter what number you choose as long as it's all relative, right? But then it starts to bottom out. It's going to eventually come to 0, which means it's actually increasing here. And now it's increasing more, so let's just use the same kind of ones I used before since it's mirrored. And it's climbing less than it was before, but it's still climbing, so it'll be positive but smaller. And it's still positive but smaller, so it'll go 1/4. And then here it's kind of flattening out again. So a graph of f prime would look like 0, -1/4, -1/2, -3/4, and then it finds its way back up to 0, and then to 3/4, and then down to 1/2, 1/4, and 0 again. So I'm thinking it's going to be this guy right here. I'm pretty pleased with that idea because of where they change direction here. That makes a lot of sense to me. Let's check the last one and see what its derivative looks like. I should have probably just erased everything, but whatever. Okay, so the last one looks like this. And that looks like a quartile function, but let's pretend we don't know that. What's the slope here? Let's go with 8. This one maybe just a little less, we'll go 6. This one, it's kind of more like 1. Right here it's like 0 because it's flat. Wherever it's flat, right, it's 0 for the slope. It's super important. It's negative 1-ish here. So we'll go negative 1, 0. This one's going up again, 1. And then it's 0. Then it's going down again, so negative 1, negative 6, negative 8. Very mirrored, right? So if I have a graph, and I just want to start anywhere because it doesn't matter, but since they put theirs in the middle, we'll put ours in the middle. It's at like 8, 6, 1, 0, negative 1, 0, 1, 0, negative 1, negative 6, negative 8. I didn't do a very good job there, but something like that. Pretty close right here. So you see, it's not really about doing any calculation so much as being able to inspect the graph, take a look at how much it's pointing up and down, and then just graph it from left to right to see what it looks like. And by the way, little tidbit, if you ever see something like x to the third as a function, his derivative is going to look something like an x squared. So if I get a cubic function like this, I should expect either a parabola up or a parabola down as its derivative.